H over the vapor density of Y. Looking at the question, information has been given to us that hydrogen diffuses 8 times as fast as a gas Y. That means when hydrogen has 8, automatically the rate of diffusion of the gas Y will be 1, since it diffuses 8 times as fast as Y. So automatically the rate of diffusion of gas Y is 1 when that of hydrogen is 8. That is the first piece of information that we have been able to receive from the question, which is equivalent to the density of hydrogen. That's the density of hydrogen is not given in the question, while that of oxygen is given. Automatically, the vapor density of H, earlier it has been stated that relative molecular mass is equal to 2 times vapor density. That means since the relative molecular mass of hydrogen is given in the question to be 2, which is equals to 2 times vapor density. To look for the vapor density of hydrogen, you divide both sides of the equation by 2. When you divide both sides of the equation by 2, automatically it means that the vapor density of hydrogen will be 1. Then, if you put that here, density of Y is not known. Now, this is the equation. If you are now looking for dy, which is the vapor density of Y, all we need to do to both sides of this equation is to take the squares on both sides so as to remove the square root. So when we take squares on both sides, you square the you square the left hand side, it becomes this. You square the right hand side, it becomes this. Mathematically, this square can remove the square root. Then 1 square is 1. 8 square is 64, which is equal to 1 over dy. We are looking for dy. Automatically, we cross multiply. Dy times 1, dy. 64 times 1, 64. Therefore, the vapor density of Y is 64. But the question is not asking for the vapor density of Y. Instead, the question is asking for the relative molecular mass of Y. And we all know that relative molecular mass of Y is 2 times vapor density. The vapor density has been calculated earlier, which is 64. Automatically, it will be 2 times 64, and that gives us 128. Hence, the relative molecular mass of gas Y is 128. That is the answer to question number 4. Standard separation techniques. Standard separation techniques talks about how mixtures are being separated. Mixtures needs to be separated into components of interest, and this separation techniques is a tool for effective separation. We have classification of substances. There are 3 classes of substances. We have elements, we have compound, and we have mixtures. What is an element? An element is a substance which can be split which cannot be split into simpler units by an ordinary chemical process. Examples of elements. We have sodium, we have lithium, we have magnesium, etc. Compound. What is a compound? A compound is a substance which contains two or more elements chemically combined. Examples are magnesium oxide. The formula is NGO. Why this is called a compound is because it has two elements which are chemically combined. Another one is sodium hydroxide. Sodium hydroxide. This one has three elements. Why it is called a compound is because you have sodium, you have oxygen, and you have hydrogen, which are chemically bound. Mixtures. It contains two or more constituents which can easily be separated by physical means. Examples of mixtures. You have your Coca-Cola. Why this is called a mixture is because of the fact that it cannot be represented by a chemical formula, because this Coca-Cola has water plus cola plus carbon 4 oxide, etc. This that you have cannot be represented by a single chemical formula. That is why it is called a mixture. There are several separation techniques, namely sieving. Sieving is generally known because we use it in homes and is also used in the village. It is used to separate solid particles of different sizes. It is employed in the garri industry. In the garri industry, we use sieving to separate fine particles of garri from the irregular ones. The fine particle passes through the sieving into the container that you have below, while the bigger particles, which are not refined, stay on top of the sieving. So sieving enables particles to be separated. You have the fine particles below and you have the irregular big particles above. It is a very important separation technique in garri industry. The second one is magnetic separation. In the magnetic separation, it separates magnetic substances from non-magnetic particles. It is used in steel industries to remove magnetic impurities from tin ore. So if you have magnetic impurities plus tin ore, bringing a magnet near these two mixtures, it will separate these magnetic impurities from the tin ore. So that method is very important in the separation of mixture of magnetic impurities and tin ore. The next one is sublimation. Sublimation is another important separative technique. In the real situation, solid should move to liquid, then to gas. There are some substances that instead of moving from the solid state to liquid state to gaseous state, they move directly from solid to gaseous. Any substance that exhibits this phenomenon is said to exhibit the characteristics of sublimation, which means substance that move from solid to gas without passing through the liquid state. That process is called sublimation. The examples of substances that exhibit this process are iodine, camphor, ammonium chloride. Filtration is another separative technique. It is used to separate insoluble solids from a liquid. It is used in water purification plants and breweries. The pipe-borne water that we make use of in homes is subjected to this process before it can be fit for drinking and for cooking. Filtration process help us to separate insoluble solids that are not soluble, from liquid, such as particles of jams, and it is used in pipe-borne water. The pipe-borne water that we all know has been subjected to filtration process. Another one similar to this filtration process is decantation, but because of the fact that the world advances day by day, filtration is better off than decantation. Why? Simply because